Hello and welcome to the next session on Global Azure Austria. This is a very, very special session. We took the opportunity a few weeks before Global Azure that a very special guest from Microsoft is currently here in Austria, Mr. Ed Burns. Ed, hello and welcome to Austria. So we met up.
Servus.
You are speaking German. I just learned that 5 minutes ago. So we could do everything in German, couldn't we? Maybe.
Meistens, aber vielleicht ein bisschen zum Fachsprache auf
Okay,
Englisch.
very good. Yeah, German is pretty good, in fact. Yeah, Ed came to Austria to do some presentations here, and thank you, Ed, very much to take the time to participate in this interview with us. Together with
Thank
me,
you.
we have Christian Köberl here from Porsche Informatik, and we will ask you some questions. We've prepared some questions which will be definitely interesting for the developer community regarding Java and Azure and all the things around the topics that you cover in the Microsoft organization. But Ed,
Great.
before we get right into the topic, let me ask you, is this your first time to Austria?
No, I had the very good fortune of coming to Austria first as a student. Way back in 1994, I did a summer internship in Vienna and fell in love with the city and have been wanting to come back as much as possible, as frequently as possible. So another great fortune happened with the collaboration between Java EE and JSF and Graviem. They are the company, Thomas Spiegel and Manfred Geiler, who initially did the MyFaces implementation. And they came up to me at Java 1 2006, and they said, oh, you know, Ed, we're working on an implementation of your specification. I was working with Craig McClanahan, the Struts guy at the time on that. And that collaboration eventually turned into the MyFaces runtime, which is now a part of JBoss EAP and IBM Liberty and, of course, WebSphere. I was working on the Oracle implementation, Sun implementation called Mohara that is in WebLogic and Glassfish and Payara. But the long story short is they had a conference called JSF Days that was running in Vienna every year from 2008 to 2012. It eventually went to the wunderschöne Bergen in Leogang, grünen Felsen, schönen Bergen. And that was my chance to come back every year. So I'm happy to be back again. So I spoke at the user group, Java user group in Wien a couple nights ago. I'm kind of reopening jugs as much as I can. So prior to that, I was in Nuremberg. I reopened that jug. And prior to that in Berlin, restarted that jug. In person, that is. When I say restart, I mean in person. These jugs have been going along, but now after Corona, we're trying to get back in person.
Oh, that sounds great. So you are pretty familiar with Europe and in particular Austria and Germany. So great to have you back, and we hope to see you often here in Austria again.
So. Yeah.
Ed, if it's okay for you, let's kick it off and let's get started with the first question. Is that okay for you?
Absolutely.
So
let's go.
Get going. You know, in my experience, Java is very popular in Europe, especially in Germany. You just talked about it. And therefore, for many customers who consider Azure, its support for Java is pretty important. How would you rate the attractiveness of Azure for Java developers today? What were the biggest improvements in the past months? And where do you still see a little bit of room for improvement in the future?
That's a great question. So I'm going to start from the outermost section and work inward. And it's really important when we talk about technologies to remember the human aspect. And these technologies are invented by and created and collaborated by humans, and they are eventually used by humans. So our Microsoft journey started a long time ago with my colleague Asir Selva Singh at Azure at Microsoft, sort of ringing the bell saying Microsoft needs to continue to grow our Java support. So he was a long time lone voice in the wilderness as Microsoft was learning, well, we need to go after not just .NET, we need to go after Java and JavaScript and Node and PHP and Python and all of those things, because as a public cloud provider, we cannot afford to pick favorites. But that was a bit of a culture shift because Azure itself started out as Windows Azure in 2010. And eventually now it's just called Azure. We don't really think of it as Windows Azure anymore. It's just Azure. So Azure was able to convince the management to say, yes, we need to go big into Java. And that starts with hiring people. So I was kind of like the second wave, maybe even third wave of of hirings into Microsoft Azure from other companies. But as a result, now we have at least 8 different individuals who are Java champions, myself being one of them, at the Microsoft organization. And so as a Java champion, I take very seriously bringing the Java lifestyle to my work. And so we try to meet Java developers where they are, using tools that they're already familiar with and using idioms that they're already familiar with. And this manifests at a very high level by introducing Maven plugins and Gradle plugins for all of the technologies that we have for Java on Azure. And at a more intimate level, having really good codes, IDE support. We have our own Visual Studio Code Java extension that we developed in collaboration with Red Hat that's got an enormous pace of innovation, and it's got project support, it's got very good Maven support, it's got IntelliSense code suggestions. I could go on about how great VS Code Java is. But at a more macro level, we have a huge number of runtimes and services that are working well on Azure. So, for example, any Java EE workload you have, and maybe this is a good time to bring up that URL, you can go and bring it on Azure. Yeah, so this is the main landing page for doing Java EE on Azure, which is my specialty. But we also have, of course, a super great support for Spring on Azure. And you can find some links to that if you go to the chop off the EE on that and go up a level. So as far as what is coming, what is going next, there's still a lot of room for improvement. One area that we're growing is native compilation, right? So maybe we'll talk about this later, but we see Quarkus and Graviem and Spring Native as attractive options that people are wanting to explore. And so we're going to be trying to add more of that to our portfolio.
Very interesting. Cool. Thank you very much. Christian, I think now it's up to you for shooting a Java-specific second question.
Yep, Ed, I was very happy to see you in the mountains in 2012 there, talking about JSF. I was there too and gave a talk. It was really great. It was one of the best conferences I was ever. And you were always known as the JSF guy in this area in this time. How do you see the rise and fall of JSF? Because nowadays JSF is not used anymore. And additionally, a lot of new frameworks are going back to the backend and going back to a backend-oriented, component-oriented model like Remix or Phoenix that are coming now out. How do you see this and the future of JSF coming out and the future of this web backend-oriented, component-oriented frameworks?
Sure, and I understand your question, and this gives me a good opportunity to talk about the definition of value when it comes to software. So when you have particularly a web front end is generally a very volatile space. Some architects would say you should count on completely rewriting your UI every 2 years because things change and trends evolve and come. UI is a fashion. It's a science it's also a science that's evolving as humans become more like computers, unfortunately. So we're having to adapt our own way of interacting with machines to fit the machines. Hopefully, we're making the machines fit the humans more. So it's kind of meeting in the middle. My point there is that UI is a space that churns currently. It churns a lot. But IT decisions are having a much longer time span than that. So when you say rise and fall of JSF, I can understand fall from the perspective of, would you choose this for a greenfield new project today as a UI technology? And the answer is probably not. However, there are enormous amounts of systems where these decisions were made decades ago, not decades, maybe 15 years ago, let's say at the max, somewhere between 10 to 15 years ago. And these systems are having to run still and still provide value. And I'm really happy to say that JSF is still running quite well for the needs that it has to be used for. If you're a banking customer in Austria, you're probably using JSF at some point, maybe the person you're talking to in the bank when you go there to get a loan, they're sitting in front of a console that has some JSF. I know that for a fact. As an American, if you are getting a tax transcript from irs.gov, that site is using JSF. So that's a huge amount of load going through, and it's an important system. And so those systems don't need to have the most super flashy new UI feel, as long as they're good enough. And the Prime Faces library is used in most of these cases, and that provides a very current look and feel for these things. So it's still being used, it's still running, it's still providing value. So I think that's an important aspect to look at in terms of rise and fall. In terms of next steps, I know that I was happy to hand off the spec leadership role to Arjun Times, and JSF is a part of the Jakarta project, which is how Java Enterprise is moving forward in an open standard fashion. Also, I'd like to quickly mention that Spring is also embracing Jakarta projects. There's at least 8 major Java EE APIs that Spring is dependent on. And when they announced Spring 6 and their plans to use Jakarta, that means they're embracing the Jakarta runtime environment. So you've got @inject, you've got servlet, of course, you've got JMS, you have JSR 255 resource annotation. So there's a lot of Java EE APIs that are used in Spring, and those are now coming from Jakarta.
Okay, yeah, thanks for the answer. Let us go back to the thing you mentioned before, Graviem and the native image. In the last year or so, Graviem gained a lot of traction in the Java world. A lot of people are using it, especially with new frameworks like Quarkus, and Micronaut, which make them really easy to handle. Even Spring now moved on to it. I don't know, how about EE on Graviem? Maybe you can say something about that. How do you see this usage of Graviem, and especially in the case of Azure, maybe with Azure Functions, how do you see the future and the usage of Graviem?
Well, like most things in the Java community, their existence was prompted by necessity. And when the idea of extending inversion of control, which started with a mess of XML files, then eventually came to annotations, I mentioned @inject. And if you keep expanding inversion of control, you eventually end up at functions, where the control is so inverted that all you're basically doing is writing a single method. That way of looking at things is kind of at odds with the central design point of the JVM, which is you leave it running for a long time, and it gets better because of the garbage collection algorithms, in which you can, of course, tune and even swap in different garbage collection algorithms. The runtime performance gets better the longer you leave it running. When you have inversion of control that's extremely extended to the point of functions, they're not running very long at all. They're basically invoking and going away as fast as you could possibly do so. So that was the necessity that prompted the invention of native systems such as Graal. And as a result, developers had to make a choice if they were going to use reflection or not. So the other aspect of Spring and Java EE is the ease of use and dynamism of having a system use reflection to figure out what you want to do. Can't work so well in a native compilation environment because those decisions have to be made right up front at build time or compile time even. So this world has gotten more interesting and also more fun. But there's another way to approach it, is JLink and other technologies to keep your runtime environment modular and small. Size, in terms of actual size of your Docker image, is a factor here. So you can achieve some approximation of like Graviem native speed if you have a properly tuned and sort of modularized environment where you're only using exactly the bits you need, because there's not that much on the class path. Most of the startup time problem happens because you have these large frameworks that are scanning the class path to see, oh, do I need to call this servlet context initializer, or do I need to invoke this startup method of some kind? If the class path is smaller, there's not as much of that. So, you know, we'll have to figure it out. I think that really, I'm looking to Project Leiden to be a way to allow developers to demarcate explicitly which parts of their code are going to be nativized and which parts of their code can remain dynamic, and hopefully the two can run together. But it's an impedance mismatch that needs to be solved.
How do you see the usage of EE and Graviem? Is there only the way of Quarkus now, or do you see any other?
At this point, Quarkus is leading the charge for having Java EE APIs working inside a native compilation environment. And it's doing it pretty well. It's just important for people to understand that Quarkus in its native mode is not supporting all of the Java EE APIs because of that reflection constraint that I mentioned.
That's very interesting. You know, I'm not the world's biggest Java guy. I'm more specialized in Azure. Christian is the Java expert in the round, but it's super interesting for me to hear the things that you say, Ed, in terms of work that goes into optimizing startup performance, because other programming languages that I'm pretty much familiar with, like for instance .NET, they have exactly the same topic. So it seems there seems to be an underlying topic which originates in the way that the cloud develops in terms of serverless computing and functions and so on. Super interesting thoughts. Thank you for sharing that.
And it's also great to just look at the common heritage of .NET and Java as well, and all those CLR-based languages, is they're you know, running in a bytecode virtual machine. So that's where it is.
Okay. My next question brings us to a little bit about the future of cloud and how things get there. In recent years, we have seen the rise of new cloud providers. I sometimes call them the second generation cloud, like Vercel or Fly.io, Cloudflare, which is not a CDN solution anymore. It's a cloud itself. And typically, these solutions are PaaS-based, platform as a service-based, and they're running on the edge. So they have a lot of data centers around the world, and the code is in the typical Azure world. You say, okay, I want to run this in this data center, and I want to run this code in this data center. But with these clouds, you just say, run my code, and they run it anywhere. And also, they focus a lot of developer experience. Usually, you have a service running in like a minute. You just git push it, and it works. How do you see the future of that, and how can Azure counter these new things and provide maybe something in Azure as well that helps developers?
Right. Well, first I want to mention that whenever someone talks about a schema for naming generations of things, it's a complicated and not exactly clear-cut thing, because when you mention that, the first thing that comes to mind is like Heroku, which, you know, predates Azure even. So an old colleague of mine from the conference world, James Ward, was using Heroku stuff a long time ago, like 2008 or something. I don't know when it was. It was late 2000s. And so those players, those other players are important. And I think it's exciting. I believe that innovation needs to be as broadly cultivated as possible. And there are some schools of thought that say the current economic system of having a few huge players, Microsoft, Amazon, Apple, Google, Facebook, controlling where all of the IT innovation happens or doing it all in-house can be seen to stifle innovation. So I'm happy to see innovation happening for these smaller providers. The second thing you mentioned is the ability to constrain the design space. So if you have a solution that's focusing primarily on GitOps, Git push to production, that is easier to do if you just have a smaller solution space that like basically use this other, some of the providers you mentioned, and you just stick with that. And if you talk about how do we bring that to Azure, well, of course you can do that with Azure, and many companies are doing exactly that. It's just that the surface area of the entire Azure portfolio is so vast that knowing how to do proper GitOps on Azure is not immediately apparent because there's so many other things you can do, and it just has to be broad. So I like the ideas of these other companies, and there's nothing stopping anyone from looking at what they're doing and basically creating guidance or even some solution templates that demonstrate how to do this. So the space is wide open, and I think it's good.
How do you see this handling of this edge stuff, so that you just don't choose a data center anymore? You just run code somewhere and get everything together?
Well, in practice, I think enterprises, for numerous reasons, both regulatory and performance, have to know where their code's going to be running. So there are certain environments where that doesn't matter, but when you scale it up to large enterprises that have regulatory obligations, then it gets more complicated.
Thanks.
Yeah, that's definitely the case. I have exactly the same experience when working with customers in Azure. The larger the customer is, the more importance this whole topic of governance comes into play. There are some applications like when you process some public data that you can easily move to the edge, but everything else is a pretty tough thing, and security and all these things are super important. That brings
I think some of the use cases of these edge clouds are like for really end customer facing, like internet facing stuff, and
Right.
there you can combine them with Azure to get the best experience of both worlds, I guess. So I think both will grow in the future, and let's see how this turns out in the next years. Yeah.
Absolutely, and I'll give a tip of, not a tip of the hat, but I'll mention Satya Nadella's vision of intelligent cloud, intelligent edge as a great way to capture that in one phrase. But that's what he wants to see Azure doing, and that's what we are doing with Azure.
Personally, I think that what you are doing here, Ed, is super important, because when I work with beginners in Azure, they sometimes see Azure as too large and too complicated. But in fact, that's kind of in the nature of the thing, because it is just so powerful. It offers so many things. And in my experience, it helps a lot if people like you are bringing in a little bit of the history, describing why things appeared and how they relate to each other. And then suddenly this big, huge thing becomes easier to use because you understand where should I go with which problem. So yeah, very interesting thoughts. Thank you very much.
That's a good point, Rainer, because looking at the history of a technology helps you understand the design trade-offs that were made. And when you understand the design trade-offs and why they were made, you can use the tool more powerfully.
Let's stay a little bit in this area of, let's say, process models and how we work and how we structure systems. And let's talk a little bit about DevOps, if that's okay for you.
Yeah, sure.
As somebody who works a lot with Microsoft, I have seen that Microsoft has started to emphasize the importance of the DevOps movement for modern software development teams more and more. They are arguing that a constant flow of innovation is super important, and to reduce the amount of time between idea or code to value for the customer must be reduced. And additionally, in this times, security issues are a thing, and you have to sometimes act pretty fast to get updates out to the customer. So I would be super interested in your experience in terms of DevOps in the software industry in general. And in particular, when you think of Java on Azure, what's your take on the whole DevOps story based on your experience?
That's a very good question, and it just comes back to the nature of software. One of the things I'm fond of pointing out is this software development engineer is named Philip Armour, and he has a knowledge classification scheme. And in terms of human history, how was knowledge encoded? Starting out with like brains, and then going into tools, as simple as even a hand axe, and progressing into books, and then recorded media. But the most recent embodiment of knowledge is software itself, which is unique from all of the others because it's independently executable knowledge. So when you have a piece of software, not only does it do something, but you can read it and understand, okay, this is what it does. So it's inspectable and readable. So it kind of, it's got the best aspects of a book in the sense that you can look at a static artifact, but it's also got the flexibility of a brain in some sense where it can actually take action. And now I'm not even talking about the insanity of having AI systems that learn, and then they learn so much that you have to have discoverability systems that you can ask the model, well, why did you learn this? How did you learn it? That's a completely different thing. I think that's for the future. But I'd like to tie this back with what you talked about with DevOps, because if you have software as every step of the process, nothing is done manually, everything is automated, then it's a little bit easier. At least you have a shot of someone new coming into the organization, looking at the artifacts and saying, okay, this is where we need to change the version of log4j that we're using, or this is where we need to apply a CVE patch to keep things up to date. But I really like noticing that CI/CD is something that has been encoded in the software culture for a really long time. Carnegie Mellon had this capability maturity model, which had a 1 through 5 level of maturity for software organizations. And at the highest level, you had like repeatable processes where you are automating, you're improving the processes. And the fact that CI/CD and DevOps is now so widely practiced across the industry just shows the maturity that we've had. Maybe we'll hopefully get to the point, this is a debatable topic, but having proper licensing for software developers, as you do have for architects and doctors and other people who are producing critical infrastructure. There's no such thing as that for software. But maybe we'll get to that, because now we have a level of maturity in the industry where DevOps is seen as table stakes. You have to have it now. But the underlying principles that enabled this were, remember when test-driven development was a new thing? Well, you could look at test-driven development and getting that practice widespread as a necessary precondition to getting the DevOps lifestyle to be widely practiced, because you can't do DevOps unless you have good unit tests. And then you also have to add onto that integration tests. And then as soon as you add a certain level of complexity, you have to have the ability to have different kinds of environments, database configuration A, database configuration C. And as soon as you have these different kinds of configurations, you have to have an ability to stay on top of how we're running all these different things. So I had the really good fortune of working with Kosuke Kawaguchi when I worked at Sun. It was a really fertile time for innovation, because we had all of this Spring and J2EE and JSF stuff was happening, but that's also the birth of Hudson. And it started out as just a simple cron job with a web front end. And now, if you look at that progression of time, we have GitHub Actions, which is, in my opinion, the most endpoint refinement of the CI/CD lifestyle. Another factor that was important in DevOps is the embracing of Git across the world. And that came really with just GitHub saying, we're going to go big. We're going to say that GitHub is the place where the world builds software. Now, they couldn't say that if it wasn't for Linux and Git being invented as the way that Linus could, keep his model of control over how kernel patches were coming in. So there's so many enabling factors: automated testing, version control, distributed version control, as done by Git, compared to like SVN or Perforce or CVS. There's so many other ones. Well, I guess Perforce had a distributed model. Excuse me on that. But most version control systems that came before Git did not have this distributed pull request model. So those factors all came into play to enable the DevOps lifestyle. But I do want to give a historical perspective here. One of the things I had a fortune to do in the past was work on Netscape 6, which was, Mozilla at that time. And the first production quality CI/CD system that I saw was involved in Netscape 6. It was called Tinderbox, and it was a system that was built for doing cross-platform builds. It had a concept of runners because Netscape had to run on native compilation on Windows, Mac, several varieties of Unix, Solaris, HPUX, IRIX, AIX was another one, of course. And so it had runners, it had a idea of submitting jobs, and it had a web interface that was built using CGI and animated GIFs and colors and tables. So all of this was done a long time ago, and the ideas are now fully in production, and I'm hoping that everyone embraces the GitOps lifestyle.
Mm. Yeah, we've come a long way. Just yesterday, I'm teaching continuous delivery here in Salzburg at university, and I just talked about the history of continuous integration servers, and I just talked to my students about setting up the first continuous integration server here at Porsche Informatik 2001 and 2002, and it's not that far away, and now everything is running on that, and it's a lot of things that have been done in the last years that enabled this continuous integration DevOps model, and it's really cool to see all that.
Absolutely. Absolutely. I also teach at a vocational college here for computer science. And if I look back in the last few years, how such regular things like passing in a homework in such a school has been revolutionized with things like GitHub Classroom. I can hand out some homework stuff with some unit tests. They can come up with the algorithms, and GitHub Classroom will gather the homeworks, run some actions on it, give them feedback immediately. I can give feedback through pull requests. The world has changed a lot in all different aspects, and also in education. I fully agree on that. That also brings me already to our last question. Time is flying. And the last question I asked Christian that if he would be okay if I ask it, because we always ask a question around education. You see, the Global Azure Austria, the event for which we do this interview here, is organized by the Coding Club Linz. And our Coding Club is proud to have a very strong focus on education. We run, for instance, Austria's largest and most active Coder Dojo. I don't know if you are familiar with the Coder Dojo movement. It's programming clubs for kids between 8 and 17 years all across the globe. And in this programming club, and also in the school, young coders often ask us, hey, what programming language, what platform should I learn? They ask us for recommendations. And my question, I think I know the answer, but maybe you can elaborate on it a little bit. Would you recommend Java? And what are your general thoughts about Java and Azure in education?
That's a great question, and I'm glad to see the Coding Dojo movement is embracing teaching the coding concepts to kids. But as someone who has I have a bachelor's degree, so not that much proper computer science education. Most of my experience has been, after graduating, I graduated from the University of Illinois in 1995 with just a bachelor's and have been learning as I go. The reason I'm bringing that up is I hope that the coding dojo movement strikes a good balance between practical skills of like coding, this is how you build something and this is how you get it running quickly, and theoretical skills of designing good algorithms, building systems that manage complexity in a way that humans can continue to understand them as they evolve over time. I mean, I know these are certain more advanced concepts, but it's important in education to have a long view and remember the foundations. And here's an example. When we look at the history of JSF over time, the reason it stuck around for a while in part was because it used proven patterns that were done from computer science in the 1960s. So a model view controller, for example, was part of Smalltalk with Alan Kay back in the 1960s. So that's not new. And these other new frameworks that are out there, they're using the same ideas in a different way, but the foundations are there. So I had the good fortune of interviewing a lot of different developers over the years, and I collected their interviews in this book, Secrets of the Rockstar Programmers. And one of the developers I talked to was Max Levchin. He was a co-student of mine back at University of Illinois Urbana-Champaign, and he went on to co-found PayPal and Affirm and Yelp. And, he's one of these people who's had the honor of having a stipple image of himself in the Wall Street Journal. So that shows you how far he's progressed, and he's doing great. But when I asked him, like, what's new and how do you stay on top of what's new, he accurately pointed out, there's not that much new from year to year. So education needs to focus on the foundations. Now, to come back to your question about Java as a choice for starting out, I would say it's a better choice now than it was maybe 8 years ago, because they have been focusing on making Java easier to learn. For example, there's a new, it's not new anymore, but there's a thing called JShell, which is a read, evaluate, print loop for Java that shows you how to, lets you just write Java interactively, like you would expect if you're coming from like basic programming. Type in the code and run. That's essentially what the read, evaluate, print loop does. So Microsoft is coming out with a Java Beginners series of videos that focus on these foundational getting started things. This is a collection of 5-minute videos. It's not out yet, but we're working on it. And also the JCP, Java Community Process, has a Java in Education working group that's headed up by Heather Van Cura and Ken Fogel. Ken is one of the Java champions, and he's a professor of computer science also, or recently retired, actually. So he focuses on education. So Java is a better choice to get started now than it was in the past, but it does suffer from one thing you mentioned, Reiner, which is the surface area problem. You mentioned it in the context of Azure, where someone new coming to Azure, they look at the surface area and say, oh my goodness, this is so huge. How do I get started? Java is the same way. And it also has APIs that are not considered the best practice anymore, but they're still in the runtime. So if you, as a student, come to look at Java and say, show me the API doc, you get this huge thing. So for an education perspective, it's better to really constrain what we show to the students to just the bits of Java that are relevant and current and representing good practices. But that's something that is overlaid. You could think of it as like a view on top of all of Java. You've got to give students a curated view that makes sense for them.
Yeah, that makes very much sense. Fun fact, you know why most kids and young coders come to us and ask us for Java? It's one major reason, and it also comes from Microsoft, and it's called Minecraft. It's Minecraft. Right. It's always Minecraft. They want to write Minecraft plugins, and we really should not underestimate the importance of games and the fun that young people have with games, and they are drawn to things like Minecraft. And I think we can really use that. And especially when it comes to Java, it makes perfect sense to take Minecraft, to have a playful approach to the whole topic of computer science, because once they understood that this is a lot of fun, then you can come up with the things that you mentioned, Adam, which I agree are very, very important. The theoretical underpinnings, absolutely.
Right. But one of the things that we've gotten better at in Java, and I hope that we continue, is this: you can't have fun when you're continually hit with frustrations. So, and it's really important in a beginner experience to not have things fail right away. You want people to try things and they work. And I remember after the TU Wien meetup the other day, the organizer, Dominic Dorn, told me angrily about the first time he used JSF and how file upload, which should be a simple thing, didn't just work out of the box. So things need to work out of the box for students especially.
That's true.
Absolutely.
But file upload is not trivial.
No, it's not. You're right.
Okay, I have to keep my eyes on the watch a little bit, and I think we reached the end of our available time. Ed, I think I can speak for both of us, Christian and me. We really enjoyed talking to you. It was an inspiring 3/4 of an hour. Thank you very much for taking the time. Thank you for being here in Austria, visiting various coding communities. And we are looking forward to visit you again in the future here in Austria.
I hope so.
Thank you very much.
So enjoy the time in Austria. Thank you, Ed. Thank you, Christian, for the awesome questions. Thank you, viewers. Enjoy the rest of the day here at Global Azure Austria. Thank you for being with us, and have a nice day.
Thanks. Bye.
Bye-bye.